Well, good morning. It's actually almost noon, and our HVAC guys are back to work on the wells, to actually connect the pipe on the wells. So we'll be seeing that in a couple minutes from Greg. This video is going to be a little longer because of the all of the stuff that we're going to be talking about, and I'll be back at the very end to tell you how much water this system uses, or how much is going into the wells, the 9 wells. And so give me a thumbs up if you like the video. Talk to you later.
See that 2-inch line that goes all the way down? We have another line that stops right here. Okay, that 2-inch line's got to feed all the way down there, turn around and come back to there. This one starts here and then it goes bonk, 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 and ends at the end. And that's a turn it around.
So how does the manifold come into effect here?
Well, there really isn't a manifold. Not like some systems where you do coils.
Right.
And you have to manifold all that together.
Right.
This is what's called first in, last out. There's we got 9 holes here. So 1, 2, 3, 4, and on the 5th hole, that should be the balance point. All these pipes are the same length down. All these sections are the same in between. So we should have a balance point on the 5th hole. So we're going to be moving, what are we going to be moving? We're going to be moving 5, 3, about 15, 17 gallons of water a minute through the 2-inch line.
17 gallons a minute?
Yeah.
Wow.
9. Okay. So and here's our 2 tubes coming in. This one's going to come like this.
Okay.
This one's going to go okay, so that means, and the water's going to run this direction, come back that way. So that means this well is the first one in,
right,
but it's the last one out.
I see.
So what that does is that puts our balance point right in there. If I have screwed up on the distance between these,
right,
or if I have screwed up on the distance of each of the wells,
right,
what it will do is it will push that balance point back this way and this way.
Right.
If my balance point is right there, that means I'm going to get 3, 6, 9, 12, 14, 16, well, whatever the numbers are, 3, 6, 9, 12,
15,
3, 6, 9, 3, 6, 9, 12, so there's 24,
right,
and 3, so actually I'm not going to be doing 17 gallons, I'm going to be doing 27 gallons a minute.
Okay.
That's what this system will produce, and each of the wells is going to be 2 to 3 gallons of water down it. Okay, so if my balance point is not here, that means these are getting 3.5 gallons a minute, these are getting 2.5 gallons a minute, and vice versa. So if my balance point is exact right in the middle, and the only reason why it will be is because everything is equally balanced out.
Right. In
the pipe distances between them and all that garbage.
Okay.
And all these are 305 feet.
I thought they were 250 feet.
No, they're 305.
Okay. Cool. So, question everybody keeps asking me is, let's say that I didn't have this system and I just had a standard compressor system, and my electric bill was $100 a month to run that air conditioner.
Right.
With this system, what does my power bill do?
Well, right off the bat to start with, it's a third less air conditioning than a conventional system. That's to start, just right off the bat.
Okay.
Okay. Conventional system has to have strip heaters to compensate for the lack of capacity when it's
cold
30
outside.
degrees outside.
Right.
Same, but the same with at the top end of the scale. The top end of the scale, a 3-ton system at 100 degrees is only a 2-ton system. This system's the same capacity all the time. It has flat capacity. You know, there's no up and down curves, no
right.
Scale. So as far as so $100, so right off the bat, $33.
Less.
Yeah, right off the bat. Then the second one is how much more efficient the system itself runs. These systems are about 50 SEER. 14 SEER is the minimum rating.
So
actually,
so in California, I had a 16 SEER system,
yeah.
And this is a minimum of 40 SEER, as I understand it.
Yeah, yeah. Well, there is no actual relationship between the energy ratings between a conventional system and a geothermal, because they use different types of material to transfer heat.
Right.
Conventional system is an average seasonal energy efficiency ratio, SEER. That's an average 12-month period.
Right.
This system is a 29 EER, okay, which is kind of like, what do you call that when it's right now? Like real time.
Instantaneous or automatic.
Yeah. It's a every minute. That's what the energy rating is. On a conventional system, the cooler it is, the more efficient it is.
Right.
The hotter it is, the less efficient it is.
Right.
Okay, so, you know, if you have bunches of 100, if you got 6 months of 100-degree weather, well, you're losing 6 months, you're losing 1/3 of your air conditioning system, but you're paying for all of it. You know,
right.
I mean, you have a mechanical fitting, you have a mechanical something that does something.
Mechanical joint.
This is just melted together.
So it becomes one piece.
It becomes one piece. Yeah. Technically, it's one solid piece of pipe, no matter we'll have 50 fittings on it or not.
So we're down here at the last well now, and we've got it hooked up. Well, actually, we've got the 2-inch pipe hooked up. The well pieces, the 1-inch, aren't hooked up yet because we're doing the 2-inch first. And so they're up here at the next to the last well, waiting for the heater to heat up so they can connect it. And they're laying out all the pieces. Okay, so now we're hooking up the actual well openings to the actual pipe. So there's the first set is down there, second set is here, and they've just started on the third set, and they'll continue, and you'll see all of the big line is. Okay, so we've actually got all of the wells, all 9 wells are hooked to the pipe that go all the way up into the garage. So the next step is to actually fill this pipe with water and do a little pressure testing to make sure there are no leaks before they cover it up and before they extend the pipe from the base of the garage up to the top and then over into the air conditioner. So we got a step closer here.